Hello everyone. Today we are going to solve problems from CSES problem set, and the topic that we are going to solve is sorting and searching. So let's first go to the first question, which is distinct numbers. The question is, you are given a list of n integers, and your task is to calculate the number of distinct values in the list. Okay, so the first input line has an integer n and the number of values. The second line has n integers, which is basically the values that will be given, and you have to find the distinct values. The sample input given is 5 2 3 2 2 3. The output is 2 because there are two distinct values, 2 and 3. Okay, so what we can do is we can sort the array, and then when we will sort the array, all the numbers which has the same value will come in one place as a group. For example, if we sort the array, this array, then the array will become 2 2 2 and then 2 3, sorry, 3 3, right? So there will be 3 twos first and then 2 threes first, then 2 threes. So we can then count the total number of distinct elements. So let's see how we can do that. I'm including algorithm header to use the sort function directly. Right now, what we can do is uh, we can traverse the array. So for example, in the given test case, that is 5 2 3 3 2 2 3, after sorting the array will be like this: 2 2 2 and 3 and 3, right? So at any index, we can check if the value at this index is exactly same as the value of the previous index. If this is same, so we don't need like that, so we have the same values, so we can skip that. And if the value is different, that means we got another new distinct value, right? So let's have a variable for count, and let's have previous value as v of 0. It's there will count will at least be 1, right? Because n is at least 1, so there will be at least one distinct value, and we'll run a loop from 1 to the last element, and we will see that if the current value is equal to the previous value, then we don't have to do anything, we can just keep doing that. Else, if this is not the case, then we have to increase the count. Means we got a new distinct value, the previous value has to be incremented to v of I, and yeah, that's it. But also there is a case that will be failing, that is if the last element, let's say the last element is 4, right? So 4 is a distinct value, but we will not count this element because we are going only to till n minus 1, right, till this index only. So instead of that, what we need to do is we need to go till n, and then we have to check that if uh, I is less than n, and this is case. Otherwise, if vi is not equal to previous value, as well as I or I is equal to n, right, uh, then we have to increase the count. Okay, so this will only happen if I is, let's say, less than n. Now we have to think what will happen if I is equal to n. Okay, yeah, even if I is less than n, if I go till this point, then also I will calculate this 4 as a distinct, right? Because at any given I, we are increasing the count only if the number at this position is a new number for me, right? So we don't need to consider that condition. So this condition is not required. And we can go till there, yeah. At the end, we can just see of the count. Let's see. The number that we have to give is 5, and there is 2, 3, 2, 2, and 3. Okay, there is a segmentation fault. Just digging in. Okay, here. So I have not initialized vector with the length, so initially it has a 0 length, and then I am directly doing v of I, c in v of I. That's why it is giving a problem. Now let's do this. 5, 2, 3, 2, 2, 3. The answer is 2. So let's do another one. Let's say 8. 1 2 3 4 5 6 7 8. Answer is 8. Let's do another one. 6 1 1 1. All the same, so it is giving 1. I hope this will work. Let's submit this. Accepted. Another way, so I did this because the topic is sorting and searching, but we can do this in another way because we need to know the distinct values, right? So we can use a set for this problem as well, because set only stores the distinct values. So let's just do that also. That will be a lot more easier. We don't need any of this. We need this line. We don't need a vector. uh, we don't have to sort it. We don't need any of these things. So let me just include set, and let's create an object of set. And then for each I'll take the element and I'll insert it into the set, right? So set will only store the distinct values only once at a time. So at the end of it, whatever will be the size of the set will be the number of distinct values, right? So let's compile this, run this. Let's say 5 2 3 2 3 2 is equal to. Let me submit this. You can see the code is different here, right? Set. It is accepted. Let's go to the next problem. There are n applicants and m free apartments. Your task is to distribute the apartments so that as many applicants as possible will get an apartment. Each applicant has a desired apartment size and they will accept any apartment whose size is close enough to the desired size. The first input line has three integers n, m and k, the number of applicants, number of apartments, and the maximum allowed difference. Okay. The next line contains n integers a1, the desired apartment size of each applicant. If the desired size of an applicant is x, he or she will accept any apartment whose size is between. Okay. The last line contains integer m integers b1 to bm, the size of each apartment. Print one integer, the number of applicants will get an apartment. Okay. In m given, k given, ei, vi. Okay. So here there are 4 applicants who has the desired size, and these are the size of the apartments, and the maximum difference that they can afford is 5. Okay. for this, let's say it will only accept apartment uh, 65, or whose size is between x minus k and x plus k, 55 to 65, which is 60 is one of them, so it can take that. So what we can do is, because k is same for all the applicants, right? We can sort both these arrays, and um, let's say that, okay, let me just comment it here. Hmm, let's say the size that is required after sorting is, let's say, a1, a2, a3, and a4, let's say, for example. And the apartment size, the apartments that we have is, let's say, b1, b2, for example, b2, b3, and b4, right? So what the first applicant will accept is a1 minus k to a1 plus k, and similarly what applicant 2 will accept is a2 minus k to a2 plus k. So in within this b1, if let's assume that b2 lies between a1 minus k to a2 minus a1 plus k, right? And b1 is below that, like smaller than this, because these are sorted, right? So b1 is definitely smaller than b2, so definitely b1 is smaller than a1 minus k, and this a array is also sorted. So we know that a1 is, what do you know, we know that uh, a1 is less than a2, right? And b1 is less than b2. So if b1 is less than a1 minus k, then definitely this will definitely imply that b1 is also less than a2 minus k. In fact, b1 is less than a2 minus k, 3 minus k, 4 minus k, all of this, because these are all increasing the values of a. So b1 is not going to be suitable for any of the applicants, so we can simply skip that apartment. And once we got b2 for a1, then we can search for a2 after b2 from b3, and again that thing will continue. So like that we can, I think, we can give the maximum apartment possible to the applicants, and there will not be any edge case or corner case there, I guess. Yeah, right, because we are considering all the possible combinations, right? We are trying, like, we are going greedily to trying our best to give give at one apartment to the applicants. But yeah, if the apartment is not, the size of the apartment is not falling between applicant's paper size, then we are ignoring it. So yeah, I think that will be the optimal way to uh, give the give a seal the apartments. So let's just do that. Let's take in M and K. Okay. And we have to include that algorithm here to use the sort function. So there will be an array of in size n and an array of size m. Next, sort both of these. Next, we will take two pointers. One is 0, let's say, and p2 is also 0. p2 is pointing to b and p1 is pointing to a. So while p1 is less than a dot size, and also p2 is less than b dot size, what we'll do is we'll see that while b, the apartment size, the current room size is less than or equal, while this is either greater than okay, while this is less than, okay, let's just do this. So if um, e of p1 plus k, which is the maximum value that the p1 client wants, is less than b of p2, then when like all the right elements of b2 will not be, cannot be assigned to a, right? So we can just do p1 plus plus, else while a of while b of p2 is less than a of p1 plus k, and it is less than or it is greater than b of p2, sorry, a of p1 plus k, we can do p2 plus plus. We can do p2 plus plus only if, only till this is less than uh, less than a of p1 plus k, right? So we are basically skipping those apartments, and then if we see that b of p2 after incrementing or skipping all those b uh, less than or equal to a of p1, here it will be minus, if less than equal to plus k, that means we found apartment for AP1. So we'll increment the count, we'll have a count variable as well. We'll increment the count as well as we'll only increment the count, and we don't need this one, this line. At the end, we can do p1 plus plus. Okay, so if bp2 is greater than ap1 plus k, this loop will not even run, and then it will also check here. If it is less than equal to only, then it will do the count plus plus, and if not, then it will simply ignore the p1 applicant. Let's do this. A of n error implicit. Okay, sorry. Forgot to include vector. Let's give it 4, 3, and 5. Then answer is 3. Okay. Okay. Here also I have done one mistake, I guess. Here you have to also check that p2 should be less than b dot size, and here also that p2 is less than b dot size. It's still giving 3. In m and k, just taking a, b to m. p1 0, p2 0, a dot size, b dot size. B of it is, for example, in this case it will be 30, and your P1 is 60. It will check if was 16 it is less, then it will go to P2 plus plus. It is 60. So this loop will break. It is less than equal to 65. B2 is less than M. Count plus plus, then P1 plus plus, then 45. Okay, so this is sold. So we have to do another P2 plus plus here, because P1 got the P2th apartment. No, it is giving. I think now it will work. K from 0 to I think. Let's submit this. Accept it. Okay.